My toolbox for fully procedural cloth sewing, stitching and details in Blender is currently in beta testing, but it has become way too complex for me to showcase in my usual tutorials. So for a change, here is a try at a kind of different, more devlog video format to show you the progress I made in the asset pack. And to showcase the progress, I have this beautiful work in progress mesh made by Virgil Bioza in Cloth 3D. So first I'm just going to rename the UV map name from Cloth 3D to the default UV map name in Blender, which is just UV map, so that it can be recognized more easily by my modifiers. And then let's right away move on to the more impressive feature I implemented, which is to allow to create complete seams and stitches between two different panels of a mesh, regardless of the deformation. For this, all we need is just to select a side A and side B attributes for the two sides of the seam, and then let's add a modifier right after the Alembic Cache modifier, which allows to bring in the animation from Cloth 3D. And here I want my seams presets. I'm just going to select the A side and B side I just set earlier. And right away we have a first seam that is instanced over the whole junction. So here we can of course set a bunch of different parameters, such as the thickness and the general width of it. Here the seam profile by default is just the two pieces of fabric put together with a piece of taping on it, but as of now I have a few other presets, such as lap seam, French seam and a kind of sleeve set. We can also edit the shape without having to touch to the generating curve profile, and right inside this modifier I can also add some stitches on top of it, with also a bunch of different presets. And if this is not enough, I can also add a bonding on top of everything. And the best thing is that everything is really stable for any kind of animation or deformation. As you can see here in proportional editing, you can stretch your mesh anyway and it will be computed in almost real time, which allows to bring a bunch of details to your mesh even after simulation or animation. And here, if I switch to the render view, it even extrudes the UV map, so there is no stretching or anything like this on the newly created geometry, because this modifier basically creates new geometry on the edges. So now, how does this work? Well, the whole setup may appear simple on this side, but it is in fact a bunch of groups, inside groups, inside groups, inside groups to make everything work, but I'm just going to walk you through the main steps to make everything work. So basically, the first step and the main prerequisite is that the two edges you want to seam together are right next to each other. For it to work the best, you also want to have the same topology, so that each point on one side is in front of another point on the other side, but I also implemented a kind of correction if there is one point right here, so that it can also sample the middle of an edge on the other side, and so on. So now inside my modifier, the first step right here is that we are going to iterate over the two sides, so one side and the other, and do a sample nearest and sample index for the nearest edge of the other side of the selection. Then with this, we are going to sample a bunch of different attributes for the other side, such as its position, its normal value, and some other attributes I compute in specific node groups, which are the tangent of the seam and its binormal direction, which is the direction on which we want to extrude our hem, and we store all of this in a bunch of named attributes. Once this is done, I just have the mesh I want to edit, and also right before everything I just selected the part of the mesh on which I have the attributes I already set, and this is just computed with a bunch of accumulate fields so that I can only select those parts, and all the rest, which are going to be left untouched, are just going to go straight through the output so that everything is a bit more efficient. So now, right after I set the attributes, I'm still left with basically the same mesh as before. So now the first step before extruding everything is to leave a bit more room for the seam, because right now, if we are going to extrude everything, there will be a bunch of overlaps. So for this, I made some displace modifiers, which are just going to kind of shrink the mesh in a certain direction, which in this case is just the opposite of the binormal direction I talked about earlier. And basically, here we are going to leave all the room for the width of the seam we set in the modifier. Now in some cases, if the seam is too big and the topology is too tight, we may have some overlaps, such as right here. So for this we can also blur a bit the deformation so that it will be a bit more stable. So as you can see, if I change the width, everything is moving accordingly. I will go into more details for this group a bit later, because we can also use it in a standalone way in the modifier setup. Then here I have a new step to compute a bunch of attributes, because right now each side is aware of a bunch of attributes for the opposite sides, but we also want to know the general direction of the whole seam for each couple of points, and the general seam normal, which will be direction around this way. So in this case it's quite trivial, but if I take out a more complex example, here I have a seam which is going all around this shoulder, and right here the two normal on the two sides is about the same, but under the armpit we have one normal going this way and the other going this way. So we need to compute a bunch more attributes to know the arc over which we are going to extrude our seam. And these steps also makes correction for another specific case, which we can also see on the other mesh. So for example right here, I made a seam between this part of the mesh and this part, but if you can see closer, this part of the mesh already has a seam, which means that under the seam, the normal of the mesh on this side is in one direction, and on the other side it is in the complete opposite direction, even though, as we understand it as humans, the global direction of the seam is still in this direction. So at this step I am also computing some attributes to reverse the direction of the normal if we detect that we already made a seam before, so we make sure that it can still extrude everything in the right direction. Now let's go back to our demo mesh. So at this step, the mesh still looks about the same. So now it's finally time to extrude the seam. And what do we have right here? You may recognize it, but this is the group to hem setup we made in a previous tutorial, so I already went kind of in depth about this, even though I made a bunch of changes on it, but here is a quick reminder of how it works. So it takes as input a mesh with an edge on which we have stored the attribute of the binormal direction in which we want to extrude and the normal direction of the mesh, and a profile curve which might look like this, with a few points along it. Then we are going to iterate over as many points we have on our profile curve, and for each one we are taking the distance between the two consecutive points and converting its transform direction into the local direction along the mesh. So if the direction is just along the y-axis, we are just going to extrude in the binormal direction, but if it goes along the two direction, we are also going to extrude along the normal direction. And this done over all the points of our curve profile and all around our mesh gives an extruded hem all around it, which works in the local direction along the edge of our mesh, whatever the orientation or deformation of the mesh is. Now if we will just use this setup like this on our seam setup, it wouldn't really work in a case where the two edges are more perpendicular. So if our two edges look like this, and we move them with the previous step so they are around this way, if we just extrude them, we'll just have a sharp corner like this. But what we would want is a smoother curve like this, so the direction kind of gradually changes as we are progressing along our seam. So the first implementation of this I made was using way too much math to kind of make a path with different parts, two straight parts connected with a circle arc made with some points and some radius. But it was on one side way too complicated to implement properly so that it can work in any kind of direction or any angles between the two different parts, and most of all it isn't really flexible beyond the simple control of the radius of the corner. And also, when the two edges are right next to each other, the new point it will create will just go into infinity. Whereas in the real world, if you bend a piece of fabric right along a seam, the bend will look a bit more like this. But in any case, before I show you my workaround, what we need from the profile curve, so for example the profile curves for the seam might look like this, when we are extruding the different points of our profile, we want to know how far along the whole dimension of the seam we are. So for example, this point will just have a parameter of 0.5, this one maybe 0.15, and this one will be really close to 1, and so on. And this parameter will allow us to know at which part of our curve we are and bend the local space of the points so that the extrusion of the hem will turn around our curve. And now for my solution, instead of using math to compute this curve parameter, I created a base surface which will drive everything. So here you can see on one side a really sharp angle with the bend I showed you earlier, and the opposite direction. And so this surface represents along the y direction all the different angles between the angles between the normals of each side of our seam. So on this side we have 180 degrees between the two different normals, and on the other side it will be minus 180 degrees. In the middle right here we have the two normals facing the same direction, so an angle of 0 degrees, and somewhere right here we have 90 degrees, and so on. So this surface represents on one side the angle between the two sides, and on the other we just have the position of the points we want to extrude along the general seam. And with this, how to know the position of the different points? It's really easy. I UV unwrapped this surface in a kind of square shapes, which I then put into an exact square shape in the geometry nodes, so that, for example, a UV position of 0, 0 corresponds to these points, which is an angle of 180 degrees between the two sides, and a position of 0, 0 is this side, and for a given angle, we can move a point all along this curve, just using some sample UVs. As you can see right here, if I go into my group to hem setup, in the group which makes the different extrusions, so here we have the repeat zone I talked about earlier, which iterates over all the different points of our curve profile. Here I just have my toggle, which allows to use my seam mode if this node setup isn't used as a modifier. And here I have a group which is called compute seam point position, which takes as an input the sampled position of our profile curve and outputs a new offset value depending on the angle between the two sides and the progress along the curve. And right inside it, our ruled surface as I showed you, which we are sampling in UV space for some parameters. Then, because this surface is just oriented into world space, I am just decomposing the different components of the vectors to reorient them in the local space along the edge of our curve, which are all stored into a few named attributes which we computed in the first step. So this is the source position, the opposite normal, and the source normal, the global seam normal, and so on. And this all allows to extrude our seams in the local position along the edge. Then on the other side of it, I just have a version of it which is just a simple flat junction, which just creates a flat surface on which I can instance the stitches. I won't go over this group again because I also made a few tutorials about this setup already, but then basically I'm able to get my curves and also what will be a bonding tape. And this is about it for the main working principle of the whole seam setup. So as you can see, it integrates a bunch of other groups which can also work as other modifiers. So the group to stitches, the group to hem, and the displace selection. So let's also use this on the front of the piece to demo some other features. So right here, I want to cut the mesh along this line in a procedural way, then displace it to make an opening, add two hems on either side, and also instance some buttons and so on. So for this, the first step, as usual, is to make our selection and add this to a new vertex group, which I'm going to call split. Here I just have a simple utilitary geometry nodes group, which is a split at selection. Let me just rename this for clarity. Here I just want to set my attribute method as island index. So here we can't really see the effect of this node group right now, but the working principle is very simple, as we are basically just making a split edge at selection, but there are a few twists to implement some more stable features. So first of all, it will be really nice to get the attributes of either side as outputs. So the new side A and side B created by this split operation. And for this I implemented two methods. First is an island indexes. So in this case I cut the mesh all the way through. So before we only had one mesh island, but then we have two different mesh islands. So based on the indexes I am able to recover the attributes on one side and the other, but it might be more complicated in some cases. That's why I also implemented a method which uses side markers. So this is just something where we need to set another vertex group. So for example, in this case, where I made this whole selection, I could just have selected a few points on this side to make sure that the A side would select all the points which are oriented on this side only. And this is a way more stable method if we are doing some splits which are not going straight through the whole mesh, such as pocket holes, buttonholes, and so on. And I also have a toggle to remove the corner attributes from the output section, so that if we make a small slit, the corners aren't always on the side attributes. Now, with this split operation, I want to displace the two sides, so let's add another geometry node group and use my displace selection. Here I want the A side I just created the output of this split selection, so this is this attribute, which also figures right here, and here I can just set a value for the binormal offset. So this principle is already the same as I showed in the seam setup, so as before, to avoid overlaps, I can also blur the selection a bit, so the other points are also moving. And here, because we are using this operation as a kind of standalone, as you can see, we can also add some tangent offset or even some normal offset to move everything. And of course, this will be really consistent even if the mesh is animated, which might be really useful in some cases. But in this case I just want the binormal offset because I want a small opening. Now I also implemented a few other controls for this node group. First I'm going to talk about the edge correction method. So to show you how this works, the base method with which I compute this displacement is that I take the direction of the cut, which gives me a tangent direction, and from this I am able to compute a direction which goes away from this, which will work just fine for all the points inside the mesh, but on the edges, if this edge correction is set to none, this point will just go along this direction, so it will go kind of outside of the base mesh, as you can see right here. So the edge correction method, which can be set either to nearest edge direction, which will just sample the direction of this edge right here, is a bit more stable, but I also have an edge curve sampling method, which in this case is about the same, but might be more stable if this edge will not be just flat, but a bit more wavy. Also, we can compute everything in the object space, so that is to say, in this 3D view, or we can also make those edits right into the UV space, so this would basically just move everything being flat and then compute back the transformation over the mesh in the 3D space. And because of the way this is implemented, this is way more stable regarding the mesh distortion. So for example, if I were to use this display selection mode on this shoulder, if I were to move everything in the workspace, this shoulder might just move this way, but if we are computing everything in the UV space, all the movement will be confined to the original shape of the mesh, so the movement will just follow the base flow of the topology. Now that we have our opening, let's add our hems on the two sides, so this will be really easy, as we already showed in other tutorial, this is working really well. New parameters I want to show you, so let's add another geometry node, which will be the group to hem, and my selection will just be my split attribute, which right away gives me two hems on either side of this new opening. And of course, the UVs are properly extruded, so the base UV of everything is working properly. And also while we are in the rendered view, I have another parameter on the display selection, which allows to select the behavior of the UV distortion, which is either in a move way, where everything is just moving with no impact to the UVs, or in shrink mode, where everything is moving, but the UVs are being way more stable. Now back to the hems. As for the seam, I added a few controls to edit the global shape of everything without having to edit the base curve profile. I also implemented a few other default profiles, so we also have a double hem, a simple flange, kind of teardrop shape, rope hem, and this one, for example, which is called simple binding, is the new way I operate the binding I made in a previous tutorial. So before we had one setup to make the hems and one setup to make the bindings, so it will create some geometry this way. But now everything is in the same setup, so that means that if we have our profile curve, two different curves, we can extrude a binding, so another piece of fabric on top of it, and the hem in the same operation, which is the case, which is what we have right here. So here we have our base edge, and we extruded a binding on top of it. And for this, I have a few new settings, so that we can basically edit the shape of this new floating piece of fabric which was added, so we can twist it, override the material if needed, and add some normal or binormal offset. And I also added the stitching in the same node group, as is the case with the seam I showed you earlier. And also, while I have the stitch in the viewport, let me show you that I also implemented a really simple animation slider for the stitches, in which we can animate the progress and basically the width and height of the effect. So with any kind of stitch we can instance, we can make a really cool animation of everything being stitched. I also have an experimental setting to also animate the hem, but this is still work in progress. And now to complete this short demo, let's just quickly instance some buttons and some straps in between those two different parts, which of course will be stable within this simulation. So here, let's just add another geometry node group, which will be the object bind to UV to instance the buttons. And here I just want to do this operation right before we split everything. I also made a tutorial about this method, but quickly I can just unwrap the model. Here I already made the 3D model of a button, which is looking like this. So with this group, what I want to instance is the collection containing the button, which is called instance on mesh in my case. And here, instead of just duplicating the button over the whole mesh, which I could do, because I want several copies of the same button, I can just take a mesh, which is for now an empty mesh, which I called buttons instancer. So let's just select this buttons instancer as my object, and in the instancing tab I am going to set instant collection on object. So now basically whatever vertices I put into my buttons instancer, which will correspond to the UV coordinates set up right here, those coordinates will be used to instance copies of the buttons on the deformed version of my mesh right here. So let's go to the split view to see this a bit better. So I'm going to take my buttons instancer, go into edit mode, and add a single vertex. Here I also need to use my toggle, which is called apply scale, because the mesh exported from Claw has a non-uniform scale, as you can see right here, and this is all taken care of into my node group, but this just means that I can use this 2D UV map to instance my button on the mesh. So I'm just going to temporarily disable my hems and the split and displace in order to quickly position all my buttons as I want them. And of course, this is really stable also with the animation. Disable the unwrapping and duplicate this to also instance the straps. For the straps, I already made a 3D model, which is just right here. And in this case, I don't want to instance everything based on the vertex position of my buttons instancer. I will just instance the straps collection based on the different copies I will make right now. So here I'm just moving everything so my straps are positioned around my buttons in the 3D view, and let's quickly make a few copies of it. So now what is the main difference we want between the buttons and the strap? So basically the button will just be some rigid objects, whereas for the straps we want them to bend with the mesh. And this is why I added a new parameter, which is to allow for this group to support surface deformation, and now this will make sure that those instances of the objects based on the UV coordinates will conform to the surface of the mesh. And with this new functionality, we can basically make any kind of patch, straps, or any kind of cloth detail which we added later, so it can also be pockets and so on, to conform to the deformation of the mesh without having to use the convoluted surface deform modifiers which come with Blender. Now I can hide my unwrapped model and my instance collection, and now right after I did this, I can add back my split, displace and hems. So now I have a really cool opening with some instance buttons and strap, which are all computed procedurally and are stable to any kind of deformation I will be able to make on my mesh, which is really nice to add a lot of details after the simulation. So that's about it for the most recent updates to my asset pack. There is still a bit of work to do before it is finally stable and ready for release, but in any case it will be released before the end of the year. Feel free to ask any question if you want to know something, and make sure to leave a comment if you also have ideas for future features and improvements. I hope you liked this video. Thank you for watching and see you next time.